Let's say we have a function defined as f of x is equal to x squared. And again, you notice I use this parabola a lot, but I think it's a great way to explain a lot of things. And so let's start by graphing this function. Our y-axis, our x-axis, and again, as we know, y slash f of x. Alright, so we know this parabola looks something like this, and in this video I'm just gonna I only care about the right side, so from zero to infinity, this side. So that's the only side that I will be graphing. Let's say what we want to do is we want to take the area under this parabola, so the area under this parabola from 0 to 1. So we'll say this is x equals 1, and so we want to bound this parabola right here. And what we want to do is we want to take the area under this parabola. So let me color in the area we want to take to make it a little more clear. So we want to take this area here. Alright, so let's think about what we can do. Well, let's assume we don't know any calculus, we don't know any integrals. So let's see if there's any estimations we can make, or perhaps any, if we can perhaps actually find the answer without calculus. So first of all, let's see if there's any geometric formulas for this. Well, we know that there's a formula for area of a triangle, and that formula is 1/2 base times height. And to me, this sort of looks like a triangle, but it looks like the hypotenuse, quote unquote, the hypotenuse is a bit curvy, right? So it's not necessarily a triangle. But I think it's a good estimation for us to call it a triangle, and to find an area that's close to the area under this curve. So let me draw a triangle that is a close estimate to that area that we want to find. So I'm going to draw the triangle from the origin to this point right here, like such. And so essentially we're going to find the area of the triangle, and notice how the extra area is this part. And so this part will be essentially added to the green part, right? So our actual area of the green part should be less than the area that we're finding right now. Let's find it. All right, so we know that the base is 1, right? The length of the base is 1 of this triangle. Well, and the height is also 1. And the reason why we know the height is also 1 is because at x equals 1, f of x is also 1. So this height is also 1. So we plug that into our calculator, or formula. We get 1/2 times 1 times 1, and that's just 1/2. So 1/2 is a good estimate of what our area is. Now let's try to estimate the area a little bit better. What if we draw rectangles like this, starting from here? And the way we would know this, so let's draw 4 rectangles. So we're going to draw 4 rectangles, and so to draw 4 rectangles that are equal in length, or in width, delta x has to be 0.25, and I'll show you what that is in a second. And then our y, or delta y, will be determined by the value of the function. So it will be something f of x. So let me show you what this exactly means. So first we'll start at 0.25 with x. So we'll draw a triangle. And our height, again, will be determined by the value of the function at this point. So our rectangle, I meant as a triangle. So our rectangle should look something like that. The next rectangle we're going to draw will be 0.25 after that rectangle. So right here. And again, our height will be determined by the value of the function at that point. So right here, this point will be the height. So our rectangle will be this right here. The next one will be 0.25 away again, and the height will again be determined by the height of the function at that point. So that rectangle right there. And then lastly, our last rectangle will be at 1. Again, it will be 0.25 away from 0.75. So it will be right here. And then we finish it off like that. And now what we're going to do is we can easily find areas of rectangles, right? And in this case, it looks like the area of the rectangles might be a better estimate might be a better estimate of our parabola area. So now we're finding the area of the blue shading. So let's do that. Well, first thing we know is that the base lengths of all rectangles are 0.25. So the area of the blue part is going to be 0.25 times the height of the first one. Well, the height of the first one will just be 0.25 squared, because that's the height at that point, plus, again, 0.25 times the height of the second one, which is determined by the value at 0.5, so 0.5 squared, plus 0.25 times 0.75 squared, that's the height of this third one, and then plus 0.25 times 1 squared, which is just 1. So this one's just going to be 0.25. And so we can plug this into our calculator, and we get a certain value for the area of the blue shading. So let's do this. Let's see. So 0.25 times 0.25. Let's plug this into our calculator. You can use Desmos for this. So the first value we have is 0.25. I mean, we can essentially write it as 0.25 to the third power. So that's 0.015625. So 0.015625 plus let's see, 0.5 squared times 0.25. So 0.5 squared, or sorry, 0.5 squared. So 0.5 squared times 0.25, and that is 0.0625. So 0.0625 plus, almost done here, 0.75 squared times 0.25. That's we'll just estimate it to be 0.141. 0.141. And then lastly we have 0.25. So let's add these values. Let's see what we get. We have 0.015625 0.015625 plus 0.0625 plus 0.141 plus 0.25. So we get 0.469. So we'll say 0.47. So 0.47. And notice when we evaluated the value of the triangle, we got 1/2, which is 0.5. And notice that this value, 0.47, is less than 1/2. And we did say that the parabola looks like, the area under the parabola looks like it's less than the area of the triangle. And in this case, the area of the rectangles is in between the area of the parabola and the triangle. So it seems like the area of the rectangles is a good estimate. Alright, now, so we'll stop there for this video. In the next video, we'll discuss more in detail on why we did this.